As part of your Christmas assignment, you were given this booklet to do during the holidays. A book of 2 sets of questions. The first set of questions, as you open the booklet, were non-calculator questions. There were 9 questions in total, which I'll go through and show you various ways to solve them. So 9 questions, all non-calculator, from the little symbol at the top. Then just over halfway through the book, you've got question 9 here. You've got exam questions 2, and these are questions that you are allowed to use the calculator. Now with this, we have a bit of an issue where it goes from question 5 to question 7. There is no question 6, and there are 8 questions in total. So that was your assignment for the Christmas holidays. Okay, on the home page for this video, you should be able to see shortcuts to the YouTube video questions. Now, all you need to do is, for the non-calculator ones, press the question number on the left, and the calculator questions, press the number on the right. Let's start going through the questions then. The first part of the work booklet had exam questions 1, where there were 9 questions, all non-calculator, so they have this symbol in the top right-hand corner. Question 1 then. Write down the number marked by the arrows. So this is a question on scales. So to work out what each of the smallest steps is worth, look at your large gap. So from 400 to 500, we have a gap of 100. And then count the number of steps to get across the gap. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. So a gap of 100 with 10 steps means that each step is worth 10. So now to work out where the arrow is pointing, we know that's 300 here. So 310, 20, 30, 40, 50, 60, 70, 80. So 380 is worth 1 mark on the answer line. Question 1b. Again, similar question, reading scales. So here we have a gap from 5 to 6 of 1, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps again. So each step is worth 1 divided by 10, which is 0.1. So to work out where our arrow's pointing, it's 6.1, 6.2. So 6.2 is worth 1 mark. Question 1c. Now this time we have to place an arrow on the scale at the number 34. So to work out what each of our smaller steps is worth, again, look at the large gap. So from 20 to 30, there's a large gap of 10, and then we have 1, 2, 3, 4, 5 steps to get across the gap. So each of the smaller markers is worth 2. So here, to find 34, 30, 32, 34. So our arrow needs to point there for 34. And again, that's worth 1 mark. Question 2. Daniel buys 1 loaf of bread costing £1.18, 1 tub of spread costing 94 pence, 2 jars of strawberry jam. He pays with a £5 note and he gets 30 pence change. Work out the cost of 1 jar of strawberry jam. And this question really is testing you on decimals, how to add, subtract and divide with decimals. So let's have a look. The loaf of bread is £1.18 and the tub of spread is 94 pence. So let's add them using our column method. 8 and 4 is 12, so 2 carry the 1. 9 plus 1 is 10, plus the other one is 11. 1 carry the 1. Don't forget to line up the decimal point. And 1 plus 1 is 2. So for those 2 items, it's £2.12. He pays with a £5 note, So we have to take our £2 12 pence from £5. And again, you can use the column method. So that becomes a 4, becomes a 10, cancel it out, it becomes a 9, and that becomes the 10. So it's 2 from 10 is 8, 1 from 9 is 8, and 2 from 4 is 2. So £2.88. However, he also gets 30 pence change. So we need to take another 30 pence off this to work out the cost of our strawberry jam. So that's 8, 5, 2. So the 2 jars of strawberry jam cost £2.58. We need to halve £2.58 to work out the cost of 1 jar of strawberry jam. So you can do it in short division. £2.58 divided by 2. So 2 goes into 2 once, 2 goes into 5 twice, remainder 1, and 2 goes into 18 9 times. So the price of 1 jar of strawberry jam is £1.29. So for your 3 marks, the £1.29 is 1 mark, some form of calculation to work out from his change how much the existing items cost, and then a division to work out how much 1 jar costs. Question 3, and this is about Samina, who's recorded the maximum temperature and minimum temperatures on each day for 6 days in January. The table shows her results. Write down the lowest temperature. So this question really is, do you understand the number line and negative numbers? So if we have our number line here with 0, and we look at the temperatures, the lowest temperatures, which are here, this is testing that you understand that -5 is actually lower, because it's further to the left, of -4. So the lowest number I can see here is -5. So our lowest temperature for 1 mark is -5 degrees C. Question 3b, work out the difference between the maximum and minimum temperature on a Wednesday. Well, we've already got -4 on our number line here, and it goes all the way up to +2 degrees during the day. So all we need to do is work out that it's 4 degrees to get to 0 and another 2 degrees to get to +2. So for our 1 mark, it's a 6-degree change. So from -4 all the way to +2. Finally, the minimum temperature on Sunday was 5 degrees higher than the minimum temperature on Saturday. Work out the temperature on the Saturday. So again, using our number line and 0 here, the minimum temperature on Saturday was -2 degrees. So it wants us to go 5 degrees in that direction. Well, if we go 2 degrees that way, we end up at 0. So we have another 3 degrees positive. So the minimum temperature on Sunday was +3 degrees C. Question 4a. On the grid, draw an isosceles triangle. Well, an isosceles triangle has 2 sides the same length. So whatever you draw, you need to exaggerate it so the examiner can see that 2 sides are the same length. So if we pick a start point here and draw one of our sides down to, let's say, here, and do the same over here, from that center point to there, you can see that those 2 lines are the same length. And then if we join the bottom, it's quite visible to see that that final side is a different length from the other 2. Then, using the correct annotation in maths to show that lines are the same length, put a little notch in the 2 lines that are the same length. And there we've drawn an isosceles triangle. Question 4b. On the grid, draw a rectangle with an area of 12 centimetres squared. So when you're doing areas, it's the length times the breadth. Now, in order to make the number 12, we need to multiply two numbers together that give us 12. In other words, we can draw any rectangle with the factors of 12. So the factors of 12 would be 1 and 12, because 1 times 12 is 12. 2 and 6, because 2 times 6 is 12, and 3 and 4. So they're the factors of 12. So any rectangle you draw that have the dimensions 1 by 12, 2 by 6, or 3 by 4 will give you this area of 12 centimetres squared. So let's draw one that's slightly exaggerated so the examiner can see what we've done. So let's draw our 2 by 6 rectangle. So let's start here and draw our 6 down the page. So 1, 2, 3, 4, 5, 6, and draw the 2 across. So 2 across there, then 6 down, and then 2 across. And I know the area is 12 because when I multiply 2 by 6, it gives me my 12 centimetres squared. And that's 2 marks for the 2 dimensions. Question 5. The diagram shows a rectangle and a square. The perimeter of the rectangle is the same as the perimeter of the square. Work out the length of one side of the square. So in order to understand what a perimeter is, it's the distance around the outside of the object. Now I've always taught my students to pick a starting point on the shape and walk around the perimeter as if you were guarding a camp. So fill in the blanks as you go round. 2, 8, 2 and 8. Show the examiner what you're doing to get the perimeter of your rectangle. And you get 20 centimetres for your rectangle. And that's probably one of your 4 marks that are available. Then, once you've got your perimeter of your rectangle, you need to understand that a square has the same length of each side. So the 20 needs to be divided by 4, and that gives you 5 centimetres. Okay, so one of the sides of the square is 5 centimetres, because if I have 5 and 5 and 5 and 5, that's 5, 10, 15, 20. And that is worth 4 marks. 1 mark for the answer and 3 marks for your working out. Question 6. A quadrilateral has been drawn on the grid. Write down the mathematical name of this quadrilateral. Well, because the bottom and top lengths are different, it can't be a parallelogram, so this is a trapezium for 1 mark. On the grid below, show how the quadrilateral tessellates. You should draw at least 6 shapes. Now, tessellation is a fancy word for tiling, but it's tiling without any gaps at all. So you can't just randomly draw 6 of these shapes. They actually have to touch without any gaps. So if we draw one that's upside down, that's one of them. Now if we draw another one that is 3 along at the bottom and 1 at the top, that's a second one. And we can do the same here. 3 across the bottom, 1 across the top. So that's 3. Same again, we can go 1, 2, 3 across the bottom, 1 across the top. That's 4 of our shapes. 1 across the top, join it there. So that's 4. And then 1, 2, 3 across the top, bottom, sorry, 1 across the top. And because we've already got the 1 there, we can go to 3. So that's given us 1, 2, 3, 4, 5. We've actually drawn 7 shapes when it wanted us to draw at least 6. And that's worth 2 marks. Question 7. Buses to Acton leave a bus station every 24 minutes. Buses to Barton leave the same bus station every 20 minutes. A bus to Acton and a bus to Barton both leave the bus station at 9 AM. When will a bus at Acton and a bus at Barton next leave the bus station at the same time? So this is a question about multiples. When will 24 reach the same number as 20 when we do our multiples? So let's do our multiples of 24. 24, 48, 72, 96, and 120. With 20, we have 20, 40, 60, 80, 100, and 120. So the next number 24 and 20 have in common, in other words, when they will depart the bus station at the same time, is 120 minutes after 9 a.m. So if we start at 9 a.m., you need to understand that 120 minutes divided by 60 gives us 2 hours. So the next time when we add 2 hours is 11 a.m. and that is worth 3 marks. Question 8. Here are some ingredients to make 12 shortcakes. Liz makes the shortcakes and she uses 25 millilitres of milk. How many shortcakes does she make? Well, this is a ratios question where we've gone from 10 of something to 25 of something. So how did I get from 10 to 25? Well, it's 25 divided by 10, which is 2.5. So the factor that I've multiplied the milk by is 2.5. This means all I need to do for my shortcakes is multiply it by that same factor. It's a ratio. So 12 times 2.5 is 30. Because 2 times 12 is 24, and a half of 12 is 6. So how many shortcakes does Liz make? She makes 30. Don't forget to put the answer on the answer line, and that's 2 marks, 1 for the correct answer and 1 for your working out. Question 8b, the same ingredients, but Robert has various ingredients and we need to work out the greatest number of shortcakes we can make. So what we're looking for is the lowest of our factors on sugar, butter, flour and milk. So for example, sugar goes from 50 to 500 grams. So to get from 50 to 500, 500 divided by 50 tells us we have a scale factor of 10. From 200 grams of butter to 1,000 grams of butter, well, when we divide 1,000 by our 200, we end up with, cancel those out, 10 divided by 2 is a scale factor of 5. For the flour, again, we've got 200 and it goes to 1,000 grams. So it's the same factor as the butter. So that's a scale factor of 5 for the flour. And then finally, the milk, we have 10 millilitres of milk and it goes to 500 millilitres. So 500 divided by 10 is 50 divided by 1, which is a scale factor of 50. So the smallest scale factor we have for our ingredients, in other words, the thing that is restricting what we can make, is the butter and the flour with their scale factor of 5. So if the scale factor of 5 is the smallest that we can cope with, 12 times 5 means we can make 60 shortcakes. So put in 60 on your answer line for 2 marks. Question 9, the final question on the non-calculator paper. The patio is 3.6 metres long and 3 metres wide. Matthew is going to cover the patio with paving slabs. Each paving slab is a square side of 60 centimetres. Matthew buys 32 of the paving slabs. Does he have enough to cover the patio? There are 2 ways to answer this question, really. The first is to work out how many paving slabs go down each of our dimensions. So if we look at the 3 metres, that's 300 centimetres. And divide it by the length of each slab, which is 60 centimetres, 30 divided by 6 tells me I would fit 5 paving slabs that way. Now, same for the length across the bottom. You've got 3.6 metres, which is 360 centimetres, divided by the length of our slab, which is 60 centimetres. So 36 divided by 6 is 6 slabs. So it would be 6 slabs wide. So 5 times 6 means I would need 30 slabs to cover that rectangle. So Matthew buys 32. Does he have enough? Yes is the answer. And the reason for that is that the patio would be 5 slabs by 6 slabs wide. And when you multiply 5 by 6, he only needs 30 slabs. Question 9b. The paving slabs cost £8.36 each. Work out the total cost of 32 paving slabs. So this question for 3 marks is asking, can you multiply a decimal number and a large number? So we've got £8.63, and we're going to multiply it by 32. Now the trick for multiplying decimals could be that you move the decimal point and say, if I move it 2 places to the right, and remember that, it becomes 863 times 32. And I can do that in a number of ways. I can do it using the column method. So 863 times 32. 2 times 3 is 6. 6 times 2 is 12. And 2 times 8 is 16, plus the one I carried is 17. The 3 here is a 30, so we need to put a 0, a holding 0. 3 times 3 is 9. 3 times 6 is 18, carry the 1. 3 times 8 is 24, plus the 1 is 25. So now I've got, add the columns, 6, 9 and 2 is 11, 8 and 7 is 15, plus 1 is 16, 5 plus 1 and 1 is 7, and 2. So I've got 27616, but then I have to remember my 2 decimal places. So move it back 2 decimal places, and I have £276.16. Okay, so another method for multiplying these numbers is to use the grid method. So you've got a number like 863, you break it down into the hundreds, the tens, and the units. And then for the 32, you have a 30 and the 2. So now what we need to do is multiply 3 by 8 to get 24, and then 1, 2, 3 zeros. 6 times 3 is 18, and 2 zeros. 3 times 3 is 9, and just the 1 0. 2 times 8 is 16, and 2 zeros. 2 times 6 is 12, and 1 0, and 2 times 3 is 6. So now we add these 2 columns up and then add the numbers up as well. So let's have a look. 0, 0, 0 is 0. 9, 0 and 0 is 9. 8 and 0 is 8. 4 and 1 is 5, and the 2 there. So 25,890. 6 and 0, 0 is 6. 2 and 0 is 2. 1 and 6 is 7, and the 1. So now we need to add our 25,890 to our 1,726. So 6 plus 0 is 6. 9 plus 2 is 11. 8 and 7 is 15, plus 1 is 16. 5 plus 1 plus 1 is 7, and then just the 2. And same again, because we've got our 2 decimal places to move it back, it gives us the same answer, which is £276.16. And that concludes the questions on section 1, which is the non-calculator section. Okay, what we're going to do now are the second part of the booklet, which are exam questions 2, which allows calculators. And there are questions 1 to 8, not forgetting question 6 is missing. Okay, let's have a look at some of the questions then. Question 1a, write the number 4,216 in figures. So 4,216. and that's worth 1 mark. Write down the value of the 8 in the number 78561. So that is 8,000. Write down the number 3568 to the nearest 10. So when we're looking at to the nearest, 10s are what we're interested in, but whether we stick or twist depends on the next number along. And because it's an 8, which is above a 5, we go up. So it's 3, 5, they don't change. The 6 becomes a 7, and we put a 0 in there. So 3570 is the number to the nearest 10. And again, 1 mark. Jaylin has a £10 note to spend on stickers. A packet of stickers costs 79p. He buys as many packets of stickers as possible. Work out how much change Jaylin should get. So we've got £10, and we need to quite literally divide it by 79p. So the first thing is get the units the same. So if we have £10, that's 1000p, and we're going to divide it by 79. Like we said earlier, we can do this on a calculator. So when I divide 1000 by 79, I get 12.65. So what this is telling us is that we get 12 packets of stickers. When I multiply that by the 79p, 12 packets would cost me £9.48. So to work out how much change Jaylin should get to answer our question, it's £10 minus our £9.48. Again, use your calculator if you want to, and you should get 52p. So 52p, that's worth a mark, and you're working out on how you got there at the other 2 marks for a question that's worth 3 marks. Question 3. Potatoes cost £9 for 12.5 kilogram bags at a farm shop. The same type of potatoes cost £1.83 for a 2.5 kilogram bag at the supermarket. Which potatoes, or where are the potatoes the better value, at the farm shop or at the supermarket? Show your working out. So let's do the farm shop first. So we've got £9, so pounds against kilograms, 12.5. So you can do this either way. You can work out how much £1 buys you. So if we divide this by 9, it tells us £1. We have to divide 12.5 by 9. Buys us 1.389 kilograms from the farm shop. If we do the same for the supermarket, then our pounds against kilograms is £1.83 for 2.5 kilograms. To work out how much £1 buys us, we divide 1.83 by 1.83, and it gives us the £1. Because we've divided that side by 1.83, we divide the other side by 1.83. So 2.5 divided by 1.83 equals 1.366. So £1 buys you more at the farm shop. So you would write down the farm shop as £1 buys more. Okay. Question 4. The shaded shape is drawn on a grid of centimetre squares. Find the perimeter of the shaded shape. So the perimeter, you start at one point and you work your way around. So we've got 1, 2, 3, 4, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So we have 4 plus 3 plus 2 plus 5, plus 2, plus 8. Takes us all the way around. Put that in your calculator if you want to on this paper. 7, 9, 14, 15, 16, 24 centimetres for 1 mark. Find the area of the shape. When you have these centimetre square shapes, it's just simply a case of counting up the squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 centimetres squared. And that again is worth 1 mark. Question 5. P equals 3.5x minus y. Work out the value for P when x is 12 and y is 5. So we can write it out in longhand. P equals 3.5 times whatever the value of x is, which is 12, and then minus 5. Big Maths tells us to do 3.5 times 12 first, which is 42. Take away 5. Gives us 37. So 37, 1 for 37, the correct mark, and 1 mark for your working out. So that's simple substitution. Work out the value of P when x is minus 9 and y is minus 6. So again, write it out in longhand. 3.5 times whatever the value of x, which is minus 9. Then take away the value of whatever y is, which is minus 6. Looks quite strange at the moment, but we're going to tidy it up. Big Maths tells us to do the multiplication first, so we're just going to do 3.5 times minus 9 is minus 31.5. So P is equal to minus 31.5, so that's this bit of the calculation we've done, and then we've got to take away minus 6. Now here we've got the sign rule where we have a minus and a minus. So it becomes minus 31.5 plus 6. Okay, so always think of your number line. You're at minus 31.5 and you're going to go 6 in that direction. So you're expecting the number to get larger. And you would end up at minus 25.5. So minus 25.5 is your correct answer for 1 mark, and some working out to show how you got minus 25.5. Like we said earlier, there is no question 6. It seems to be missing from the booklet. Question 7. A. Solve b minus 7 equals 12. You can do this by trial and improvement, just trying various numbers, or you can use the mathematical method, which is to get b on its own, do the opposite, so plus 7 on both sides, so b is equal to 19. And that's worth 1 mark. Solve 5e equals 40. So 5 next to the e means 5 times e equals 40. You can either use the trial and error method, just try various numbers in there until you get the number 8. Or you can use the math method, which is you're trying to get e on its own. So if 5 is multiplying e, then we need to divide by 5. If you divide one side by 5, we divide the other side by 5, so e is equal to 8. And that's another method for solving it. And then for question 7c, we have 4m plus 6 equals 15. So this is a pretty standard two-step equation. Step 1 is we're trying to get m on its own, is to get rid of the plus 6. So we do the opposite and we subtract 6 on both sides, which leaves us with 4m on the left, because those two cancel out, and 15 minus the 6 is 9. Then, because we've got 4m, and 4m means 4 times m, to get m on its own, we do the opposite, which is divide by 4. So we have to divide by 4 on this side. So m is equal to 9 over 4. And that would do as an answer. If you want to use your calculator and divide 9 by 4, then that's 2.25. It's 2 1/4. Any of those answers would be correct. Question 8. Here is a shape. Draw all the lines of symmetry on this shape. So a line of symmetry is like a mirror line, where when you draw the line and look down it, what's on one side is the same as what's on the other. So that's one line of symmetry for this shape, and a line down the center would be another line of symmetry. So there are two lines of symmetry. A hexagon, write down the order of rotational symmetry. So rotational symmetry is, if I stuck a pin in the center, how many times would the shape map onto itself as I spun it around the center? And here, because it's a hexagon, it would do that 6 times. And that concludes the second paper. So second section was calculator use. As you can see, using a calculator, you still need to show your working out. Show the examiner what you put in your calculator. I hope this has been of help to you, and just let me know what marks you got for each of the sections. So if you want to add up your scores, the first section was out of 30, so just let me know what you got out of 30, and the second section was out of 23. So section 1, the non-calculator section, out of 30. The second section, the calculator section, was out of 23. So just make a note of what you got for each of the sections.